Hello everyone, welcome back to PC Core YouTube channel. Today we are going to study about logic gates and one of the type of logic gates that are basic gates. So in order to understand what are logic gates, we will define what are logic gates. Logic gates are nothing but are simple building blocks that in digital electronics that will take one or more inputs and it will only produce single output. The output produced will be of Boolean logic. It will either be 0 or 1. So this is what logic gates. Based upon its operation, there are three types of logic gates: basic gates, arithmetic gates, and universal gates. In basic gates, we will have AND gate, OR gate, and NOT gate. Similarly, in arithmetic gates, we will have XOR and XNOR. And similarly, in universal gates, we will have NAND and OR. We will study in detail manner about each of these gates. So today we will study about basic gates. So as we have one of the type of basic gates is AND gate. As we have seen, AND gate, it will have, let us say we are having two input NAND gates where inputs are A and B and output will be Y. So what is the function of AND gate? AND gate will just take inputs and it will simply do multiplication of two inputs. So if we are giving two inputs 0 and 0, then our output will be 0. And if you are giving 0 and 1, and output will be 0. If you are giving 1 and 0, and output will be 0, and 1 1, then only output will be. What we can draw is AND gate produces logic 1 only when both the inputs are 1. So this is the specialty of AND gate. If we will get logic 1 only when both of the inputs are 1. If in a circuit, if we want to design a circuit in such a way that if any of the input is 0, then if we want 0, then we will simply give AND gate there. Similarly, we will have next gate will be OR gate. Let's take two inputs A, B and Y. Output will be Y. Or let us take F, and we will draw the truth table of this one. OR is nothing just but an addition of these two inputs. So for a truth table, we are having two inputs, means total number of combinations are 2 power 2, that are 4 combinations: 0 and 1, 1 0 and 1 1. If you are performing 0 plus 0, you will get 0, 0 plus 1 1, 1 plus 0 1, and 1 plus 1, as we have seen in Boolean theorems, 1 plus anything will be 1. So the specialty of OR gate is if any one of the input is high, that is logic 1, then the output will be high, that is 1. So this is the function of OR gate, as we have seen this is in Boolean theorems as well. And one of the most important gate is NOT. You know that this this one acts as a buffer. If you are giving A, and you will get A, and it will have some delay, let's say TD as delay. If you are giving A as input, then you will get the output A only after TD time. So if I am having A and my output Y, it will be equal to A. If my A bar, this is NOT gate, no. So what is the difference between buffer and a NOT gate is gives the complement of the input. So we can also write can also call NOT gate as inverting buffer. NOT gate is also known as inverting buffer. If you are having A and output Y, if you are having 0, output will be 1, and 1, then output will be 0. So where this NOT gate is used in multivibrators. Multivibrators is very important topic in digital electronics. We will learn about it in future videos. So this is the it acts as a inverting buffer. So that these are the basic gates. Next video we will learn about universal gates or arithmetic gates, and after that completion of gates, we will go into multiply operators, one of the most important topic in digital electrics, where you will clearly understand the concept of delay. So stay tuned and subscribe the channel. Thank you.